So next we will solve some of the numerical problems which are related to the steam formation. So the first problem we are going to discuss in this session is, that is, the problem is something like this. So find the enthalpy of 1 kg of the steam. They have given us the mass of the steam, which is 1 kg. At a 12 bar, they have given us the pressure at which we need to measure all these values. And then when the steam is dry saturated, steam is 22% wet and superheated to 250 degrees centigrade. Three conditions of the steam is given. One is dry saturated steam, okay, one is wet steam, and the other one is, the last one is the superheated steam. Use the steam tables. Assume specific heat of the superheated steam as 2.25 kilojoules per kg Kelvin. Okay, so this is the problem they have given us. Okay, so we need to use the steam tables. Okay, what is meant by the steam tables is, okay, so at various conditions, with different pressures, they would have measured all the properties of the steam. For example, saturation temperature, like a specific volume, or the enthalpies at different states, and then they have tabulated, okay, in the book which is called as a steam tables, or the tables which is called as a steam table. Right now for this, what I am using is, it is a thermodynamics data handbook which is by Nijaguna and Samaga. These are the authors. Okay, I am going to use it. How to locate where is this the steam tables, or what are the values we are looking for? Like if you go to the page number 2, okay, in the index, okay, it says thermodynamic properties of saturated water and dry saturated steam in the page number 11. Okay, there you will find the steam properties for the different pressures. Okay, I am going to go to that page, that is a page number 11. Okay, it looks something like this. So here they have there are various columns. In the first column they are listed down the pressure, and then in the subsequent columns we have a saturation temperature, specific volume for the different states of the steam, and then at the end we have the enthalpy as well as the entropy for the different state of the steams we have. Okay, so we are going to use this the steam tables in order to note down what are the different properties of the steam at the given pressure. Okay, so we will try to solve this. Okay, from steam tables at 12 bar, that is a pressure they have given us. Okay, at 12 bar. Okay, so 12 bar, if I look at this, okay, in the page number 11 I will get this, the 12 bar. Okay, at the 12 bar, now I am going to note down the required values in order to calculate the superheated steam, or this a wet steam or the dry steam, the enthalpy of all these three types of the steams. Basically I need three values. One is the saturation temperature. What is the saturation temperature for that particular pressure of 12 bar? And two are one is the sensible heat, and then that is HF, and HFG, that is a latent heat of the evaporation. Okay, so if I look at this steam table at 12 bar, I am getting the saturation temperature as 188. Okay, so TS, that is equal to 188 degrees centigrade. Always temperatures are measured in degrees centigrade, that is 188 degrees centigrade. Next is, I want to calculate the HF, that is a sensible heat. Okay, if I look at this at the 12 bar, the HF is equal to 798.4. okay, so it is equal to 798.4. the units are kilojoules per kg. The units are kilojoules per kg. And then I need also the HFG, that is the latent heat of evaporation. I am going to note down that value as well. HFG is equal to, okay, at the 12 bar, and then the value of HFG is it is coming around 1984.3. 1984.3 kilojoules per kg. Okay, these are the values, okay, are the properties I need in order to calculate whatever they are asked in the problem. And then they have also given the pressure and also the superheated temperature, that is TSUP is equal to, okay, how much they have given us. So here it is 250 degrees centigrade. I am also going to note down that value as 250 degrees centigrade, and then I have this specific heat at the superheated steam is CPS, okay, it is a specific heat which is given by 2.25 kilojoules per kg Kelvin, okay. So these are the values they have given us, and then we have taken also some of the values from the steam tables. Now let us try to solve unknowns one by one. The first unknown is steam is a dry saturated. When your steam is a dry saturated steam, so what is the enthalpy of that steam they are asking us, okay. So A is enthalpy of dry saturated steam, enthalpy of dry saturated steam, enthalpy of dry saturated steam. So we know that from the previous topics, okay, so how to calculate the enthalpy of a dry saturated steam. There is one formula that is equal to Hg, that is the enthalpy of the dry saturated steam, is equal to, it is a summation of the two terms, that is the HF, that is a sensible heat, that is HF, plus latent heat of evaporation, that is given by the HFG, okay, then H into HFG, okay. So we need to substitute and simply add them together, you will get the value of Hg, okay. So what is HF from the data handbook? This is 798.4, okay. So I will substitute that. This is equal to 798.4 plus, what is HFG? HFG is here 1984.3, 1984.3, okay. So if you add them together, okay, you will get the value of 2782.73. 2782.73. Obviously, kilojoules per kg is the units for the enthalpy, that is the enthalpy of a dry steam, okay. That is the one unknown we have found out, okay. So basically we need to remember this formula, Hg is equal to HF plus HFG, and then whatever your data collected from the steam table, you substitute that one and then you will directly get the value of Hg. Next unknown what is asked in the problem is, okay, so steam is at 22% wet, okay. So now the B, unknown B is, so enthalpy of wet steam, enthalpy of the wet steam, okay. So what is meant by the wet steam? I already explained you that it also contains the steam and then the water molecules, okay. We have to find out the dryness fraction in order to find this enthalpy of the wet steam, okay. So when the steam is, okay, how much percentage wet? This is 22% wet, okay, comma, when the steam is 22% wet, okay, that means to say it is 78% dry, okay, it is 78% dry, okay. Therefore we can write the dryness fraction X is equal to 0.78. 78% dry means 78 divided by the 100, okay, so that is 70.78, okay, that is the dryness fraction what we get. Next we have this formula, we know that HW is equal to, that is the enthalpy of the wet steam is equal to HF, that is the sensible heat, plus X into HFG, that is dryness fraction X times the latent heat of evaporation, okay, that is HFG, okay. We need to substitute the values into this, okay. What is HF? We have taken from the data handbook, that is 798.43, 798.43, plus what is the dryness fraction? 0.78, 2.78 into what is the value of HFG, that is the latent heat of evaporation, is it is given by, so 1984.3, that is also we have taken from the data handbook, we have noted down here. Okay, so if you solve this, okay, so if you put it into the calculator and then solve this, okay, you will get the value as 2346.18. okay, so that is 2346.18. obviously that is, the units are kilojoules per kg, the units are kilojoules per kg. Okay, this is the answer, that is the enthalpy of the wet steam, that is 2346.18. okay, so this is the second unknown we have found out. Next we will have to find out the enthalpy of the a superheated steam, that is the third unknown we have, that is enthalpy of superheated steam, enthalpy of superheated steam. Okay, so we know that the enthalpy of the superheated steam is given by the formula HSUP, that is enthalpy of the superheated steam is equal to HF plus HFG plus CPS, that is the specific heat of the steam, it is called as a CPS, into TSUP, that is the superheated temperature, minus of TS, that is the saturation temperature. Let us try to understand this formula. HSUP is the superheated enthalpy of superheated steam, HF is the sensible heat, HFG is the latent heat of evaporation, CPS is the specific heat of the steam. They have given us, where is this? The specific heat of the steam is 2.25 in kilojoules per kg Kelvin, that is a unit for specific heat. So, superheated temperature minus of the a saturation temperature. Where is this superheated temperature? They are also given us the superheated temperature, that is 250 degrees centigrade. Where is this saturation temperature? If you remember, we have collected that data from the data handbook or the steam tables. At 12 bar, the the saturation temperature is 188. Okay, our job is to just put the values and then find out the answer. Okay, what is HF? HF is nothing but 798.4 plus what is HFG, that is 1984.3. okay, 1984.3 plus what is CPS, that is 2.25, that is a CPS. What is the superheated temperature, that is a 250 degrees centigrade. What is the saturation temperature we got from the data handbook, that is the 188 degrees centigrade. We are going to substitute that as well, 188. So we have this 798.43 plus 1984.3 plus 2.25, that is a specific heat, 250 minus of 188. Okay, so if you simplify this, okay, you will get this answer as H superheated, okay, is equal to, you will get the answer as 2922.23. 2922.43 kilojoules per kg. Okay, that is the answer for the enthalpy of the superheated steam. Okay, so in this way we have found out all the three unknowns. Okay, they have asked us to find out here. Okay, so what we have done, okay, in order to summarize that, they have given the problem. In that problem they ask us to find out the enthalpy of different types of the steam. One is wet steam, one is dry steam, and superheated steam. What the data they have given us is, they have given us the a pressure at which we need to find out those values, and then they have given us the what percent of the steam is wet, and then they have given us the superheated temperature, and then they are also given us the specific heat, that is 2.25 kilojoules per kg Kelvin. So we, in order to find out enthalpy of a dry saturated steam, we have taken this formula Hg is equal to Hf plus Hfg. This is for the enthalpy of a dry saturated steam is given by sensible heat plus like a latent heat of evaporation. So you will find this answer as 2782.73. Similarly, for the wet steam, we have this formula Hf plus x into Hfg, okay, where x is the dryness fraction, Hf is a sensible heat, and then the Hfg is the latent heat of evaporation, and then we have to we found out this answer as the like enthalpy for the wet steam. Similarly, enthalpy for the superheated steam is calculated using the formula Hf plus Hfg plus Cps into T superheated minus of the saturation temperature, that is the Ts. In this way, we can find out the like whatever the unknowns which has asked in the problems. Very important thing is we have to remember all those formulas whatever we have given it in the earlier contents. Okay, so that is the properties of steam. In that properties of the steam, you should remember all the formulas. You write them at one of the pages and then try to write it twice or thrice. You will remember those formulas, and then you should understand how to take the values from the steam table. What is steam table? Like where to look, okay, at what pressure to look, and then how to extract the values from the steam table. So if you do that, okay, so solving these problems are not so difficult. Okay, so thank you for the patient listening. Thank you very much.